So we will start with our second topic, that is hydrostatic forces on any surface. Okay, that means whenever a surface is immersed or whenever the body is immersed inside the liquid, what is the type of force which is acted on the surface. Okay, so quickly we'll see the syllabus. So last time or last in our last unit or last topic, we had started with fluid static. So in fluid static we had completed the pressure, intensity of pressure, Pascal law, hydrostatic law, as well as we had seen the different types of pressure measuring devices. Now in this topic of second unit, we are going to see what are the different types of forces acting on the fluid when it is immersed. Okay, so basically in this we are going to see what is total pressure, center of pressure, okay, on any submerged plane, and different types of plane, curved plane, submerged plane, okay, and we are going to see the numericals on them. Okay, so first of all, we will start with total pressure. Or what is total pressure? Yeah, first of all, don't get confused with total pressure and intensity of pressure. Okay, intensity of pressure denoted by small p, or simply pressure denoted by small p, it is force acting on the fluid per unit area. Okay, and this intensity of pressure, capital P, okay, it is a force exerted on the static fluid when the surface or any body is immersed inside the fluid. Okay, that means suppose this is a liquid surface and you are immersed, or you had immersed, suppose this body of any arbitrary shape, it may be a circular body, rectangular body, or rectangular surface, anything. So whatever the total force acting on the surface, okay, the total force acting on the surface of any body, either it is a plane surface or curved surface, okay, when it is in contact with the fluid, okay, that means when it is immersed in water, so this water will going to apply some force. So whatever the force applied, that is called as total pressure. It is denoted by capital P. Okay, so remember, small p, pressure or intensity of pressure, is force unit area, and that is a different quantity. And here total pressure, although the name is total pressure, but it is a force, okay, which is acting whenever the body is immersed or any surface is immersed inside the liquid. Okay, and the point of application of total pressure, okay, as total pressure is a force, so point of application of this total pressure force, it is called as center of pressure. It is similar to weight and center of gravity. We know the weight of the body is a force which the body exerts on the earth, and equal and opposite force which the earth exerts on any body, that is called as weight. Okay, and the point of application of weight is called as center of gravity, G. Similarly, whenever a body is immersed in the liquid, there is some force which is applied by the liquid on that body, and point of application of that force, it is called as center of pressure. Okay, so center of pressure is simply the point of application of the total pressure acting on the surface. Okay, now how we can observe this total pressure force? So have you observed whenever you go in swimming pool, or whenever you go in some pond or lake, so the weight of that body, or your weight, okay, suppose your weight on earth surface is 60 kg, okay, so if you will go in water and again you are going to measure your weight, so you will observe your weight is not 60 kg, okay, your weight is always less than 60 kg. Why? Because whenever you are on the earth surface, only your weight is acting in downward direction, okay, but whenever a body is inside the liquid, so the weight is acting in downward direction and the pressure force is acting in upward direction. Okay, so because of that, the net force acting on the body, it will be less than weight of the body. Okay, remember this. So total pressure is nothing but the total force exerted by the static fluid on the surface, either plane or curved, when the fluid comes in contact with surface. Okay, and it is acting when the fluid is stationary. Okay, Then center of pressure is point of application of total pressure acting on the surface. Okay, so we had completed the theory part. In this topic only there were two definitions, total pressure and center of pressure. Okay, so we will start with our first derivation, that is the total pressure acting on any surface immersed in the liquid. Okay, so we will consider any surface of any arbitrary shape. Okay, consider any surface of any arbitrary shape like this. Okay, and it is immersed inside the liquid as shown in figure. Okay, then let capital A is the total area of this surface. Okay, capital A is the total area of this surface. Then we know this surface or this body, it will have its own weight, and that weight it will be acting at center of gravity G. Okay, so consider H bar. Okay, this H bar is nothing but depth of center of gravity. Okay, depth of center of gravity from the liquid surface. Okay, then again we know whenever this surface is immersed, so there will be the total pressure force P, and that total pressure force P, it will be acting at center of pressure. Okay, so consider H star. Okay, H star, sorry, H star, it is the distance of center of pressure from liquid surface. Okay, now this is our top view and this is our side view. So in your side view, if you extend the surface, okay, if you extend the surface, so it will going to intersect on the free liquid surface, making an angle theta. So theta is nothing but the angle made by plane with the surface, okay, or with the free liquid surface. Let the plane of the surface, okay, whatever the point of intersection of this extended line on the free liquid surface is at point O. Okay, so point O represent the intersection of free liquid surface and extension of the plane. Okay, now in its auxiliary view, you can say this OO is the axis. Okay, आप जब टॉप व्यू में देखोगे ऑक्सिलरी व्यू में, तो आपको OO एक्सिस दिखेंगे, and you will have the shape like this. And in side view, you will observe the plane is a line, okay, inclined line making an angle theta. Okay, after that we will consider any strip. Okay, we will consider any small strip on the body of thickness dy. Okay, and let y is the distance of this strip. Okay, in top view, y is the distance of this strip from axis OO. Okay, and y star is nothing but the distance of center of pressure from axis OO. Okay, so okay, so we will consider a small strip of area dA. Sorry, y bar is the distance of center of gravity from axis OO. Y star is the distance of center of pressure from axis OO. After that, we will consider a small strip of area dA at a depth small h. Okay, that means this depth is small h. This strip, this depth is small h, and along in auxiliary view, its distance from axis OO is y. Okay, and its area is dA. Okay, so area of the strip. Okay, this area of the strip dA. Okay, after that we know we had considered the hydrostatic law, and what this hydrostatic law states: whenever any body is on the liquid surface, or if you consider any fluid particle on the liquid surface, so the pressure acting is atmospheric pressure. Okay, PA. Okay, and if you consider any point of fluid particle at a distance z, okay, so the pressure at a depth z is rho g z. Okay, here we are talking about an elemental strip at a distance h. Okay, so the intensity of pressure on at a depth h is P equals to rho g h. Okay, so the intensity of pressure at a depth h on the strip, it will be rho g h. Okay, and remember this pressure, it will be acting normal to the surface. Okay, pressure is always acting in perpendicular direction or normal to the surface. Okay, okay, now so the pressure acting on this strip, okay, so the pressure acting on the strip is P equals to rho g h. So pressure force acting, okay, pressure force acting on the strip df, it will be P into area of the strip. So it is rho g h into area of the strip is ga. Okay, so force acting df is rho g h dA. Okay, now this is our surface, this is our plane, and at a depth h, the intensity of pressure acting is P. Okay. Similarly, at a depth h1, the pressure acting will be P1, where P1 is rho g h1 dA. Okay. Similarly, at a depth h2, okay, the pressure acting is P2, where P2 equals to rho g h2 dA, and so on. That means on the entire surface, the pressure is continuously changing. Okay, as the depth increases, h increases in downward direction, the value of P increases. Okay, so different types of forces, they are acting on all the different points which are on the liquid surface. Okay, or which are on the surface. Okay, so in order to find out the total pressure or total pressure force acting, we are supposed to integrate the above equation, that means rho g h dA. Okay, okay, with the limit to the lower and upper surface h1 and h2. Okay, so in order to find out the total force acting, we are going to integrate this df. So total force acting on the whole area f is equal to integration of df, that means integration of rho g h dA. Now here this rho and g, rho is what? Density of the water or density of the fluid. Suppose it is a water, so it is density of water. Okay, and its value is 1000 kg per meter cube, which is always constant. Okay, and g is also 9.81, so that is also constant. Okay, now we are left with dA. Okay, now if the strip, now from the figure, if we consider this figure, so consider this triangle. This is our liquid surface, this is point O. Okay, now this is starting point of the surface, this is ending point of the surface. Here we are having h bar, this distance is h bar. Okay, this point is G. Suppose this point is center of pressure P. Okay, so this distance is h bar, and suppose this is a strip at a depth h. Okay, and uh, from point O, the horizontal distance is, this distance is y star, this distance is y bar, and this distance is y, and this angle is theta. Okay, so you can see this is a similar triangle. This triangle ABC is similar to AGX, and that is also similar to APY. Okay, so we can have sine theta. Sine theta, sine of theta is equal to opposite. Opposite is h. H upon hypotenuse is y. Okay, in bigger triangle, so in triangle OGX, sine theta is opposite is h bar divided by adjacent is y bar. Okay, similarly in triangle OPX, okay, sine theta is opposite is h bar, h star divided by y star. Okay, so we can have h by y equals to h bar by y bar equals to h star by y star, that equals to sine theta. So from this we can say h equals to y sine theta, h bar equals to y by sine theta, and h star equals to y star sine theta. Okay, so we will put this value of h in above equation. So we will have f equals to integration of rho g into y sine theta into dA. Okay, here as discussed, rho is 1000 if the fluid is water, g is 9.81, and y is and sine theta is theta made by that particular plane. So for all the strip, this value of theta is constant. Okay, so you can take rho g sine theta outside, so we will have integration of y into dA. Okay, so remember this term y into dA. Okay, so what is this y into dA? That means this is our axis O. Okay, this is our point O, this distance is y. Okay, and here there is some area dA. So you are taking the product of any quantity into its distance. Okay, so remember in mechanics, okay, you had learned the term moment. Okay, so moment of force is nothing but force into distance. Okay, similarly, moment of any other quantity, suppose moment of area. So moment of area is nothing but area into distance. Okay, so in our case, the distance is y and area is dA. So this integration, this y into dA, this is first moment of area. Okay, so y into dA, this is first moment of area, and integration of first moment of area is total moment of area. So this total moment of area is A into y bar. Okay, where y bar is nothing but distance of center of gravity from axis OO. Okay, so you can replace this integration of y dA as A into y bar. Okay, so we'll have equation f equals to rho g sine theta into y bar into A. Okay, now again from the above equation we know this, if you multiply this sine theta with y bar, so h bar equals to y bar sine theta. So you can replace this y bar sine theta as h bar. Okay, so f equals to rho g A into h bar. Okay, so the total moment of this is the formula for finding out the total pressure force. Okay, so total pressure force, that equals to denoted by F or P, that equals to mass density into acceleration due to gravity into total area of the surface into distance of that particular center of gravity from liquid surface. Okay, so आपको कोई भी प्रॉब्लम सॉल्व करने के लिए, सपोज आपको प्रॉब्लम में रेक्टेंगुलर एरिया दिया रहेगा, सर्कुलर एरिया दिया रहेगा, ट्रायंगुलर एरिया दिया रहेगा, सो आपको फर्स्ट ऑफ ऑल उसका सीजी निकालना है. ओके, सेंटर ऑफ ग्रेविटी. ओके, एंड सेंटर ऑफ ग्रेविटी का प्रॉब्लम में जो भी रेफरेंस वैल्यू है, लिक्विड सरफेस कितना ऊपर है, सो आपको उसका डिस्टेंस एच बार निकालना है. ओके, after that suppose triangle है, so its area is 1/2 breadth into height. If it is a rectangle, so it is length into breadth. If it is a circle, so pi by 4 d square. आपको area निकालना है, so area into distance from distance of CG from liquid surface multiply by G into rho, so you will get the value of total pressure P. Okay, so in this way we will solve the problems. Okay, after that we will see the derivation for center of pressure. Okay, now this center of pressure denoted by h bar, h star. Okay, so already we will continue our derivation. Okay, because this derivation is in continuation. So after calculating the total pressure force, we will calculate the center of pressure, the distance of center of pressure from liquid surface, h bar, h star. Okay, so we know the pressure acting on the pressure force acting on the strip dF is rho g h into dA. Okay, and we know this h is nothing but y sine theta, so rho g y sine theta dA. Now we will take the moment of the force. Okay, this moment of the force about axis OO. So we know moment of the force is nothing but force into distance. Okay, now distance of the strip from axis OO is y. So that is df into y. Now put the value of df, so it is rho g y sine theta dA into y. Okay, so this equation will become rho g y square sine theta dA. Okay, rho g sine theta into y square dA. Now this is a moment of force for a particular strip. Okay, 1 minute. This is a moment of force for a particular strip m1. Okay, when this point m1 is at a distance y1 or h1 from liquid surface and y1 from axis OO. Similarly, at any point 2, the distance will be h2 and its distance from axis will be y2. Okay, so its moment will be whatever rho g sine square sine theta y2 square dA. Similarly, m3 will be at a distance h3 and its distance will be y3. So moment of force dm3 is rho g sine theta y3 square dA and so on. Okay, that means different moments are acting on different points on the same surface. Okay, so in order to find the total moment, we will take the integration. Okay, so the sum of moments of all the strips about OO. Okay, that equals to integration of rho g sine theta y square dA. Okay, again here rho is 1000 for water, g is 9.81 and theta is constant for all the strip. So you can take rho g sine theta outside, so it is integration of y square dA. Okay, remember we had just seen this y into dA. Okay, y into dA, that is called as first moment of area. Okay, and if you again multiply the distance, okay, so it will be y square dA, so that is called as second moment of area. So this second moment of area, okay, second moment of area, that is also called as moment of inertia. Okay, denoted by mi or simply I. Okay, so this integration of y square dA, that is nothing but moment of inertia of the surface, okay, denoted by I suffix O. About axis OO, as you are taking the distance from axis OO, so it will be moment of inertia of the surface about axis OO, denoted by IO. Okay, so we'll put this value of IO in our equation. Therefore, we will have sum of moment of all the strip, that is total moment, that equals to rho g sine theta into IO. Okay, now, but we know the moment of force about axis OO. Okay, moment of axis we had seen. 1 minute. Suppose this is our liquid surface, this is our surface, okay, and this is point O. So the total pressure force F is acting at a depth h star, okay, and its distance from the axis is y star. Okay, so the total moment of force, that equals to F into y star. Okay, but if you are taking about the strip, individual strip, so the individual strip have the total moment of area as rho g sine theta I0 or IO. Okay, so these two should be equal. Okay, ये दोनों सेम क्वांटिटी है. ओके, जब आप इंडिविजुअल फोर्सेस ले रहे हो, एक एक स्ट्रिप का अलग अलग फोर्स कैलकुलेट कर रहे हो, सो उस टाइम पे आपका सम ऑफ ऑल द मोमेंट, ओके, वो कितना आ रहा है, रो जी साइन थीटा आई ओ. बट आप ये जो डिफरेंट फोर्स है, इनका एक इक्विवेलेंट फोर्स, रिजल्टेंट फोर्स ले रहे हो, सो दैट रिजल्टेंट फोर्स इज एक्टिंग एट सेंटर ऑफ प्रेशर, ओके, एंड दैट टोटल प्रेशर फोर्स इज एफ. So moment of total pressure force F is F into y star. So basically this F into y star and this quantity, they are same. Okay, so you can equate them. Okay, so you can equate them. So equating above to equation, we will have F into y star, that equals to rho g sine theta into IO. Okay, remember here, now what is happening in this case, this is our plane and this is axis O. ओके, अब ये प्लेन का डेप्थ फिक्स नहीं होता है, कभी ये प्लेन यहाँ पे भी हो सकता है, प्लेन यहाँ पे भी हो सकता है, बट प्लेन कहीं पे भी हो, ओके, उसका सेंटर ऑफ ग्रेविटी CG इज ऑलवेज कांस्टेंट. ओके, उसका G पॉइंट कभी शिफ्ट नहीं होगा. व्हेन द बॉडी इज इमर्स्ड, G इज ऑलवेज कांस्टेंट, बट इट्स डिस्टेंस फ्रॉम एक्सिस OO इट मे चेंज. Okay, so in order to get the more accurate formula, we will convert this moment of inertia about OO in terms of moment of inertia about G. Okay, so we know the moment of inertia about G is given by parallel axis theorem. IO equals to IG plus AY bars square. Okay, I think this is the formula you had learned in 12th. Okay, so we will apply the moment of inertia about any axis OO, that equals to moment of inertia about its center of gravity IG plus A y bar square. Okay, yeah, above equation में we had written we had divided this f, so we will have y star equals to rho g sin theta io upon f. Okay, again from above equation we know from the triangle this h bar h star upon y star is equal to sin theta. Okay, so we will multiply this here and divide here, so h bar upon sin theta is y star. So यहाँ पे हमने replace कर दिया y star को. Okay, sorry, we had replaced this y star as h star upon sin theta. Okay, so substituting the above value, so we will have this y star. So y star is nothing but h star upon sin theta, that equals to f. Okay, so f is nothing but rho g sin theta, sorry, divided by f. So it is rho g sin theta, as it is rho g sin theta divided by f. यहाँ पे divided by f था, so divided by f. F is rho g a h bar in bracket io. So io is ig plus a y bar. Okay, see हमारा इक्वेशन क्या था? इक्वेशन था y स्टार इज इक्वल टू रो जी साइन थीटा इंटू आई ओ डिवाइडेड बाय एफ. ओके, सो हमने y स्टार को वैल्यू पुट किया, रिप्लेस किया, y स्टार इक्वल्स टू h स्टार अपॉन sin थीटा. ओके, राइट साइड में रो जी sin थीटा एज इट इज, रो जी sin थीटा एज इट इज. ओके, डिवाइडेड बाय f. f इज रो जी a h, रो जी a h बार, और यहाँ पे io का वैल्यू पुट किया, सो इट इज ig प्लस a y bar square. Okay, so we will solve this. So first of all, rho g cancels from numerator and denominator. You can multiply this sin theta here, so it will become sin square theta. Okay, so the final equation will become h star equals to sin square theta upon a h bar in bracket ig plus a y bar. Okay, a y bar square. Now again we know this y bar. Okay, this y bar is nothing but sin theta is h bar upon y bar, so y bar is h bar upon sin theta. Okay, so y bar square is nothing but h bar square upon sin square theta. So you can put this value here. Okay, so our equation will become sin square theta upon a h bar in bracket ig plus a into h bar square upon sin square theta. Okay, now you can multiply this sin square theta and divide sin square theta with ig. Okay, so we will have 1 minute. You can multiply this sin square theta to ig square and divide to sin square theta. Okay, sin square theta हम multiply and divide करेंगे. So basically numerator में sin square theta रहेगा ig के साथ, and denominator will become sin square theta. Okay, दोनों side. So this sin square theta will cancel with this sin square theta. Okay, so here finally we will have, and we will open this bracket. So we will have h star equals to ig sin square theta upon a h bar into h bar. Okay, so the formula for calculating the depth of center of pressure. Okay, so this h bar is nothing but location of center of pressure. Okay, ये आपका surface है, ये आपका center of pressure P है. Okay, or it is called as CP. So उसका depth from liquid surface, so that is called as h star. Okay, so this h star is nothing but depth of center of pressure. So this h star, depth of center of pressure, that equals to ig sin square theta upon a h bar plus h bar, where h bar is nothing but distance of center of gravity g from liquid surface. Okay, so basically आपको प्रॉब्लम में कोई भी सरफेस दिया रहेगा. Okay, Suppose it is a rectangular surface. Okay, so sorry, it is a rectangular surface. ओके ये उसका टॉप भी हो गया, साइड भी हो गया. सो आपको उसका सीजी निकालना है. ओके, सो यहाँ उसका सीजी हो गया. देन सीजी का डिस्टेंस फ्रॉम लिक्विड सरफेस निकालना है. दैट विल बी एच स्टार. ओके, देन यू कैन कैलकुलेट टोटल प्रेशर एक्टिंग एज रो जी एच बार. ओके, रो जी एच बार. इससे आप उसका टोटल प्रेशर फोर्स एक्टिंग ऑन दैट निकालोगे. After that, आपको प्रॉब्लम में जो पूछा जाता है that is depth of center of pressure. So this depth of center of pressure, suppose this is point P, okay, center of pressure. So what is its depth from liquid surface? That is H star. तो H star निकालने के लिए आपको फॉर्मूला है H star equals to Ig sin square theta upon AH bar plus H bar. So in this topic you are just supposed to remember these two formulas, and based on these two formulas we are going to solve the entire unit. Okay, so basically derivation part is over. Okay, after that, suppose what will happen if the surface is vertical surface. Okay, suppose आपने जो surface insert किया that is a vertical surface. So vertical surface को extend करोगे, so with liquid surface it will going to make an angle 90 degree. Okay, so if the surface is inserted vertically, so theta equals to 90, and we know if theta equals to 90, sin theta is equal to 1. Okay, so if sin theta equals to 1, so the formula is modified, so that is H star equals to Ig into sin square 90. Sin square 90 is 1, so it is simply Ig upon AH bar plus H bar. Okay, now second case is what will happen if the surface inserted is horizontal surface. Okay, so if the surface horizontal is horizontal surface, so basically this will be point G. Okay, and on the same level we will have point P. Okay, so its distance will become h bar logically. Okay, again formula में put करो, so theta equals to 0. Okay, so theta equals to 0, sin 0 is 0. Okay, so formula will become H star is equal to Ig into sin square 0, so that is 0 upon a H bar. Okay, plus H bar. So basically ये 0 into Ig upon a H bar, this term will become 0. So H star is equal to H bar if theta equals to 0 degree. Okay, so basically आपको theta 0 के प्रॉब्लम नहीं पूछे जाते. जो भी प्रॉब्लम आते हैं वो either theta equals to 90 or any value of theta which is less than 90. Okay, after that, for solving the problem, everyone we will all these formulas are already known to you, but quickly we will revise these formulas because पूरा chapter में आपको formulas लगने वाले हैं. Okay, I think in strength of material you had already gone through these formulas. Okay, so while solving the problem, the first type of geometry which we are going to see, that will be rectangle. Okay, so for any rectangle, the rectangle is any surface which will have its breadth as b and its height as d. Okay, so the location of center of gravity from the base. Okay, if you talk this as base, so from base its location of CG is at a distance of d by 2. Okay, so remember the location of CG from base is x equals to d by 2. Then area of this rectangular surface is breadth into depth, breadth into whatever the height, that is b into d. Okay, after that, moment of inertia about center of gravity. Okay, so if the axis is passing in this direction, okay, if the axis is passing in this direction, okay, so जो भी direction को parallel है, okay, so remember the formula is parallel into perpendicular cube divided by 12. Okay, so आप b को parallel moment of inertia निकाल रहे हो Ig, so it will be b into d cube divided by 12. But if you are taking the base as d, okay, so in that case the moment of inertia will become d into b cube divided by 12. Okay, so remember the simple formula is parallel into perpendicular cube divided by 12. आपका एक्सिस जो भी साइड को पैरेलल होगा दैट मल्टीप्लाई बाय एक्सिस को जो इंटरसेक्टिंग साइड है परपेंडिकुलर साइड होल क्यूब डिवाइडेड बाय 12. Okay, so BD cube by 12. Then the next type of geometry which we will see, that will be triangle. Okay, so for triangle, suppose the height of the triangle is h and its base is b. Okay, so the location of CG is at a distance of h by 3 from base, or 2h by 3 from apex. From apex it is 2h divided by 3. Then area is b 1 by 2 breadth into height, 1 by 2 b into h, and moment of inertia about any axis which is parallel to base. Okay, so that is bh cube upon 36. Okay, after that the next type of surface is circle. So we know for circle the CG is at a distance of d by 2, or at the radius. Area of the circle is pi by 4 d square, and moment of inertia about g, that is pi d cube, pi d to the power 4 upon 64. Then the next surface is trapezium. For trapezium, the CG is at a distance x equals to 2a plus b divided by a plus b into h by 3. Then area is a plus b by 2 into h. Okay, where h is height of trapezium, and a and b are nothing but parallel sides of trapezium. Okay, and moment of inertia का formula आपको याद रखना है, that is a square plus b square plus 4ab divided by 36 a plus b into whole bracket into h cube. Okay, so ये formula आपको याद रखने हैं. So from next lecture we'll start with numerical. Okay, so wait 1 minute, I am taking the attendance.